Algebra 2 1.9c, we're going to estimate with scientific notation. So when we need an approximation or an estimate, scientific notation can be helpful. We can convert the standard notation numbers to scientific notation. If we have 780 million, we can move the decimal point 8 hops from behind the zeros in between the 7 and the 8. We get 7.8 times 10 to the 8th power. And if our numerator is a decimal like this one, we can move it -4 hops in between the 7 and the 1, and our denominator can move -6 hops to behind the 5, because we need one digit to the left of the decimal, don't we? Now we have 7.8 times 10 to the 8th, and we can write it over a 1 so we can do our multiplication straight across. And 7.1 times 10 to the -4 over 5 times 10 to the -6. We multiply this denominator by 1, and the whole thing is over that denominator, isn't it? We can regroup these with the associative and commutative properties. We can change their order and put the 7.1 over here with the 7.8, and we can put the powers of 10s together. And it's all over the denominator of 5 times 10 to the -6. Now we can factor these. We have these together, and we have the powers of 10s together, okay? So keep this in mind, because I'm going to move this whole thing up on my board, okay? So we've got them factored. The numbers on one side and the powers of 10 on the other, okay? So here they are. Now we're going to use the properties of exponents to do our exponents. And the product property says that we can add these, and the quotient property says that we could subtract these, right? So we end up with 8 plus a -4 minus a -6. Remember, when we subtract a negative, it means we add the opposite. So we're going to have 8 plus a -4 plus 6, all right? These two make a plus. So now we've got it times 10 to the 10th. We can round off these numbers so that we can estimate, and the 7.8 can round to an 8, and the 7.1 can round to a 7. So now we have to use the approximate symbol. So it's approximately 8 times 7 over 5 times 10 to the 10th, or 8 times 7 is 56. But we don't want any decimals, and we want these to divide evenly. So 5 times 11 is 55, so let's round this again to a 55. Now we need to move our decimal point over from behind this 1 on the 11 in between the two 1s. And because we did that, our exponent's going to go up, because we're moving to the right. And to write it in scientific notation, we end up with 1.1 times 10 to the 11th as our estimate. That's what it's approximately equal to, okay? Let's try this again. Now we've got a bunch of decimals, and we need to write them in scientific notation and regroup them and factor them, don't we? So this can be rewritten as a negative exponent by putting the decimal in between the 7 and the 3, and this can be written as a negative exponent by putting the decimal in between the 8 and the 4. So we get 7.3 times 10 to the -3rd, because we went 1, 2, 3 to the right, and this is times a -1 because we only went over 1 hop, didn't we? And we go over -6 hops to put this behind the 6, so now we have 6 times 10 to the -6 for our denominator. We can rewrite and regroup these using commutative and associative properties, so we can put the 7.3 and the 8.4 together, and we can put the powers of 10 together, and this is all over 6. Using the product property and the quotient property of exponents, we're going to add these and subtract these, right? So we're going to add -3 plus -1, and then we're going to take away a -6. So that means we're going to add the opposite here again, right? So we're going to add a 6. So we get -3 plus 1, -1 is a -4, but if we add the opposite here, we add a 6 to the -4, we get a +2. We can round these off. 7.3 and 8.4 can round off to 7 times 8, which is 56. But because it's a 0.3 and a 0.4, they're really larger than 7 times 8, aren't they? A little bit larger? So we've got 56 times 10 to the 2nd power as our approximation so far, but we want this to be a whole number. 56 divided by 6 is going to make another decimal. So because this is a 0.3 and that's a 0.4, let's round this up to a 60 so that we get a nice round even 10. 60 divided by 6 is 10. So if you're confused, we rounded up to 60 because our original numbers were larger than 7 times 8. Our original numbers were 7.3 times 8.4. That's more than 56. So it wouldn't make sense to round down to a 54 to make this a 9. Then we're going even farther away from the 7.3 and the 8.4. So because these were larger than 7 and 8, we rounded up to 60, okay, to have a better estimate. So now we've got 10 times 10 to the second power, and to write it in scientific notation, we need to move the decimal one hop over to the left. So we're going to add an exponent to the 10. So we have approximately 1 times 10 to the third power, which is about 1,000. Okay? So think if the original number is large, like 47 million, we use a positive exponent on the 10 to move the decimal left. So think large left. They both start with an L. Okay? So it's going to move the decimal that way, and we're going to have a positive exponent. And if the original number is small, like this little tiny decimal that's way far away from the decimal place, we're going to use a negative exponent on the 10 to move the decimal right in between the 4 and the 7. So that would be a negative exponent moving the decimal to the right, okay? And if the decimal doesn't move at all, then the exponent for the 10 is a 0. If we have 1.2 times 10 to the 0 power, we learned in the last few videos about the power rules and the rules for exponents. The zero exponent rule says when we have a zero exponent, it's a 1. So that's 1.2 times 1. That's 1.2, right? Okay, we're going to move on to 1.10 lessons. We're going to talk about field axioms and properties of equality. All right? And, of course, I'm going to have all the links for Chapter 1 that we've done so far in the description of this video. And if the list starts getting too long in the description, I may just put a link to the Algebra 2 playlist so you can go in this description of this video and just click on the Algebra 2 playlist link and then scroll through the ones you want to find, okay? Because I notice sometimes I end up putting 10, 15 links into the description, all right? So maybe it's just easier to put the Algebra 2 playlist, and then you can scroll through that playlist to find the videos you want, all right? All right, let's talk about some field axioms. I hope I'll see you there. Bye.